One example, what does this asset graph actually mean? Let's make this complex sounding concept easier to understand. Here, let's bake some chocolate cookies as an example for how orchestration can work. Let's take the ingredients and bake the chocolate cookies. And obviously we need eggs, we need flour, and in the end we want to see the chocolate cookies. And let's split this down into tasks and states, because we perform specific steps in the recipe and then we have some output. Actually, we have some input as well, or needed. That's the eggs and the flour. So let's combine this. That's the task. And the output of this is the cookie dough. And we need to process the cookie dough further and need to add chocolate. So we combine it further with chocolate. And the output of this is a chocolate cookie dough. Obviously, it's not yet the finished cookie. We need to bake this in the oven, but then we have the cookies. And this is really interesting, because if you look at this, we see that the blue colored boxes represent the tasks. And this is what normal orchestration solutions, like for example, Airflow, commonly represent. On the opposite side, or adjacent side, I probably should better say, we see the states of the magenta colored boxes. And that is the things that we actually care about. And wouldn't it be neat if the data orchestration solution would be literally caring about the things that you and I and the business is caring about? This is what the asset graph is about. So we are connecting here the states that we care about with the transformations to go from one state to the next one. But what are the implications of doing this? Let's step back and again look at the ingredients and the chocolate cookies. So we have two ways to get there. One way is the task-based approach. So we see combine, add chocolate, and bake in oven. It's already clear that a lot of stuff that we have seen before, the state that we care about, is not transparent for the computer, for the data dependencies, and thus the computer cannot act as a calculator and help us solve the data challenges. But if we look at the state that we care about, that you and I care about, and that the business cares about, we see something that is looking like a data flow graph, something that is rather easy to reason about. And in fact, this graphic structure holds all the pieces that the computer can reason about your data as well. And this is really, really powerful. So we have the task-based orchestrator and the asset-based orchestration process. What are the advantages of asset-based orchestration? Well, let's look as a first example into testing. How would you usually run a testing procedure in the task-based way? Usually, you would probably run a process that is outside of a traditional inline data pipeline. That might be a separate data observability tool or some handcrafted tests. The problem is you will very easily mix high quality data with low quality data and run into data quality issues. And it's really, really hard to make sure that your tests and the pipeline are in sync. Here with the graph, it is super easy. We can add additional data quality testing steps to the individual nodes in the graph just as needed. And we can make sure that the computation along this graph only progresses further if the tests are green. Or perhaps we can actually let it progress further if the tests are yellow and emit a warning, but the business will be alerted and will know they have to do something. The next point is freshness. Again, in the traditional way of implementing this, it is really tricky. First of all, you have to somehow keep track of the state, is it fresh or not, in some external place and then reason about this. And that can be hard. And secondly, you have to trigger all the operations all the time. And then inside each operation, figure out, is this now something that I want to execute or not? In fact, that means usually a lot of manual complexity. When working with an asset-based system instead, you can ask the individual asset or the node in the graph that you care about, that I care about, and also the business cares about. Like, are you stale? When should you be actually executing? What do you want to be refreshed? And then we can trigger the refresh as needed. And last but not least, it allows to perform new types of scheduling. In the past, So that means in the task-based orchestration scheme, we had to schedule based on explicit jobs. Now imagine your team has a job and the other team has a job, and you somehow want to make sure they are operating together. It's just a mess. Do you create a super job? How do you connect them? It is really, really hard to make data scale in the traditional job-based way and coordinating the refreshes of jobs as needed and in the right order. However, here with a graph, the computer fully automatically can take care of this with declarative scheduling approaches.